Hi, in this video we will solve more problems in Fourier sine transform as well as cosine transform. See this problem, solve the integral equation integral 0 to infinity f of x sine alpha x dx, and right hand side some function is there in terms of alpha. So if we solve this equation integral 0 to infinity f of x sine alpha x, what we will get? Actually we will get f of x. So it means they are saying find the inverse Fourier transform. So whether it's an inverse Fourier transform or inverse Fourier sine transform or inverse Fourier cosine transform. Further the next clue is here. Previous problem it was cos alpha x, so inverse Fourier cosine we found, right? Now here sine alpha x is there. So what we have to find? Inverse Fourier sine transform. So they didn't tell you explicitly that find the inverse Fourier sine transform. Okay, so fs of u is integral 0 to infinity f of x sine ux dx, and in the place of u we have alpha, that's it. Fs of alpha is integral 0 to infinity f of x sine alpha x dx. So what is f of x? Directly you can write this formula. This is just for your convenience. So f of x is 2 by pi integral 0 to infinity fs of alpha sine alpha x d alpha. So please don't miss this 2 by pi. Many times they get confused which function this 2 by pi will come. 2 by pi always will come in inverse Fourier cosine as well as sine transform. This you will write it correctly. Since it's sine, you will write sine here. So this is fs of alpha. So now what is the solution? The solution is 0 to 1, answer is 10. 1 to 2, my function is 20, and more than 2 it is 0. So 0 to infinity, I am splitting it as 0 to 1. I am writing my first function as 10. Then 1 to 2, I am writing my second function as 20. 2 to infinity, what is answer? 0. So no need to write here anything. Just 0 and just cancel this term and make it 0. So is that clear? Your integral limit is 0 to infinity. Since in your function 0 to 1, my function is 10. 1 to 2, my function is 20. And more than 2 my function is 0, so we have written this value 10, 20, 0. So now try to integrate on your own and find the answer. It looks like a very simple integration, but I hope so many will do a small mistake over here. You can just pause the video and try to solve it on your own. Then I'll give the answer. Yes, now if you see 2 by pi 10 into cos alpha x, it was sine alpha x d alpha. Okay, we are integrating with respect to alpha. So which is a constant? X is a constant. Many would have written alpha here down. So sine integration is minus cos alpha x by x. And the second one is minus cos alpha x by x. Same thing. Only constant is there 20. And just substitute the values. Upper limit, the limit 0 and 1 for the first one and 1 and 2 for the second one. When you apply the upper limit, cos 1x minus lower limit is cos 0, so that is 1. And the same way here, cos 2x minus cos x. You have to just take out the constants and simplify the rest. Okay, so please be careful when you are applying the inverse Fourier transform or Fourier sine or Fourier cosine transform. You are integrating with respect to u or alpha. In this question, right hand side is in terms of alpha, so I told alpha. Most of the times it will be in terms of u. Just be careful and avoid this silly mistake. You can write it down as a note for yourself. Now we will look into some complicated integration. Now see this question. Find the Fourier cosine transform of f of x is equal to e power minus x square. Looks like a simple question. Find the Fourier cosine transform. What is the formula? Fc of u is equal to integral 0 to infinity f of x cos ux dx. So integral 0 to infinity e power minus x square cos ux dx. How to integrate this? So by this time you might have told e power ax cos bx, and then you would have realized that ax is there, means then I can apply the formula here. X square is there, so we cannot apply the formula. So you might have studied Leibniz rule for differentiation under the integral sign. That is, if phi of a is equal to integral a to b some function f of x comma a dx, then phi dash of a is equal to integral a to b del by del a. This is partially integrating with respect to that constant. Here along with x some constant will be there, no? Partially differentiating with respect to that constant f of x comma a dx. So this is the procedure to find the integral values in such cases. So fc of u will become fc dash, that is the derivative. Okay, so here derivative is there, and then my integral limit is 0 to infinity. Same here, what is a constant along with x? U. So del by del u of the function which is there inside dx. So what will happen when I integrate with respect to u? Okay, so in that case the other value x will be a constant. Okay, so if you see that e power minus x square is just a constant, I am partially differentiating with respect to u. So cos ux differentiation is minus sine ux into x. Okay, so this is very important. Just mark this x as very important. You can see that the student has corrected by writing u first. Okay, again, since we are partially differentiating with respect to u, x is a constant, so cos differentiation is minus sine ux into x dx. So we get this integration, that is integral 0 to infinity minus x e power minus x square into sine ux dx. Now we have to integrate it, so we are going to use integration by parts. Okay, so which one is going to be u and which one is going to be dv is the next question. Okay, why? Because the main aim is I want to bring back my question in the right hand side, because left hand side is a derivative. So right hand side, if I get the question, it's easy for me to solve it further down. So right hand side I want my question, that is nothing but e power minus x square cos ux in the integration part. So integration is second part, right? So when I will get cos ux by differentiating sine. Okay, so I am going to take this as u and minus x e power minus x square as dv. I have written the same thing separately. Now it's easy for you to check. Yes. So now if you see this, this is u. So u is sine ux. So du is differentiation with respect to x. So we got du as u cos ux, and dv is minus x e power minus x square dx, right? So we have to integrate to get v. So put minus x square as t. So minus 2x dx will become dt. So minus x dx will become dt by 2. So now minus x dx I have replaced by dt by 2, e power minus x square. So e power plus t, and dt will be there. Already dt is here, so no need to write one more dt. So when you integrate e power t, you will get e power t, and this is just a constant. So v is equal to e power t by 2. So t is nothing but minus x square, replace it again. So e power minus x square by 2. So what is the formula? uv minus integral v du is the formula. So we are just substituting the values. Okay, so u is sine ux and v is, just now we got e power minus x square by 2 minus integral v is e power minus x square by 2 and du is u cos ux. That's it. So now this first term, because of e power minus infinity is 0 and lower limit sine 0 is 0, so automatically first term will become 0. So only second term will be left. So 1 by 2 we have written as it is. Okay, so we have taken u outside, so minus u is there. And what is there inside this? Integral 0 to infinity e power minus x square cos ux dx. This is nothing but your question. So your right hand side becomes minus u by 2 fc of u. So fc dash of u is there on the left hand side. Bring this fc of u down, that's equal to minus u by 2. When we integrate with respect to u, A function's derivative is there in the numerator, function is there in the denominator, means we'll write log of that function. So log of fc of u, and here we are integrating with respect to u. So if you integrate this value, if we integrate u on the right hand side, you will get u square by 2. So already 1 2 is there, so we will get minus u square by 4 plus some constant. Okay, so left hand side is log is there, so I want to get rid of this, so I am raising to the power e. So fc of u is equal to e power minus u square by 4 plus some e power c. E power c is some constant, I am naming it as k. These are all just simplification. So fc of u is equal to e power minus u square by 4 plus k. So this is a solution, but still I want to find out k. This is the procedure. So when we are going to substitute a particular value to find the value of k. So when u is equal to 0, fc of 0 will become k, okay, because this will become, here there is one small mistake. When you raise to the power e and this comes in multiplication, correct? So e power minus u square by 4 into e power c. So this is into k, so it's in multiplication. So when u becomes 0, so e power 0 will become 1 into k. So fc of 0 will become k. So now we have to find fc of 0 by using the given question. What is the question? 0 to infinity e power minus x square cos 0 dx. So right hand side this k as it is we are writing. So in the question just replace x by 0. So cos 0 is 1. So we get k as root pi by 2, because this is just the direct formula, correct? So fc of u is nothing but e power minus u square by 4 into this k value whatever you have got, root pi by 2. This is a direct formula. Integral 0 to infinity e power minus x square dx is root pi by 2 by using the gamma function. So this problem is slightly different. So we are not integrating just like by using regular methods. We are integrating by using Leibniz rule for differentiation under integral sign.